Kirill Merkushev, and I'm working in a company called Vivi. And today I would tell you a story on how did we adopt Pulsar in our Healthtech startup as a heart of event source system. So I'm on position of responsibility for any kind of server-side development, any kind of infrastructure development in Vivi, and I'm actually keen into quite a lot of open source communities, and I love to code Java and Go, and I was quite for a while contributor for iReactive.com project, so please check it out as well. I work in a company which provides and builds a digital healthcare platform, and as Allianz-based startup, we are responsible for a mission building the leading digital health stage platform for personalized interactions toward better health. And we have as an application in the company organizational platform on the web available, as well as mobile site applications and a backend system on top of AWS to glue everything together. So from the very beginning, we wanted to do quite a lot of stuff. We do scalable system with components as independent from each other as possible. And that led us to event-driven, reactive, and in particular, event-sourced approach. What means event sourcing here? Event sourcing means that we do not interact with microservices directly, but more we communicate via some event storage and event source. Small events representing minimal changes of the overall state of the system, be that change of the organizational properties or user account management. Each microservice then pulls all the events from event source, event storage, and applies that as a by action to local database. And these local database could be quite optimized for use case of that particular microservice. So we mostly use DynamoDBs to store key value pairs of different kind of information, and same time on other microservices we could use any SQL database or just in-memory caches to show up something as a latest information. All that kind of stuff brings us to reactive Losscoupled architecture, which is sometimes hard to design, especially when you have to plan ahead all the events within the new feature. You have to think about different approaches of usage of these kind of events. You have to think about extensibility of that kind of events, so you wouldn't have dozens of similar events to the same case where you have to fix something in your system, but just one event which would be extensible enough and would self-contain. However, when it's hard to design at the very beginning, it pays off at the end, because it's really nice to extend that kind of system. And at any point of time, we could recreate the entire knowledge in one microservice about all the users, all the organizations we have, and build something on top of that kind of information, business related and quite customizable. And that wouldn't require us to add more load on other microservices or change them to survive new load. And new microservices are really easy to experiment with. It's really easy to discontinue them, as well as events which are not used anymore, we could just ignore them and nothing happens with other microservices not depending on them. We've built our system without much of framework usage, and we use Spring Boot as our main framework for development and Webflux for API development, as well as Reactor library to do everything internally. That brings us quite a lot of reactive capabilities with back pressure, with retries, and declarative approach of coding. On the event source system itself, we use bare minimum, which are just events, reactions, and source itself, where all events are stored. The source keeps all the events in the form of JSON structure, where we write down what kind of event type is that, and this event type defines what other fields you have to expect in the data structure and what kind of information you could collect from these events. Sometimes this is just a simple indicator that new batch of information appeared, or for user account management events, we have to store sometimes personal information, simple personal information, which is, for example, email. For all the events, we have a specific key. Key is a user ID, unique user ID, which represents an aggregation where all the information regarding some user would be ordered always within the same order with exact timestamps of what happened, and that would give us quite nice timeline of what's happening with each user in our system. By the key, using the key, we sharding our databases, we sharding our event source to storage, and that brings us to the story itself. So how did we adopt Kafka and Pulsar later on? We first started with something similar, and that was a Kafka as a quick start, because Kafka provides quite a lot of experienced engineers writing a lot of information around. Community is really great and provides a lot of quick starts. That was super easy to start. And we anyway thought that later we would offload it to some service provider. However, after some time, we decided that better to do something internally with event storage, keep that in our company, and grow our own expertise to deal with our event storage. When we finally understood that Kafka was probably not the way to go, we've built and something on top of that. And why we did that? Because Kafka was hard actually to operate on a big scale, and that requires sometimes quite a lot of knowledge on how to deal with that and what kind of stuff have to be deployed. Second was not available non-blocking client at the moment of adoption, and yeah, that wasn't play well with our approach of everything non-blocking and reactive. And because of that, we searched something with more appropriate client. Besides that, Kafka is known as broker, where all the brokers are highly coupled with the storage. So you cannot really move brokers around without dealing with the storage. And since we use event storage system where storage is quite important, we cannot lose anything of the storage. we have to deal with increased complexity of upgrading Kafka carefully, of extending that later on carefully. So that was something we were afraid of when uh, you operate as a small company. So our event gateway abstracts away any kind of communication with underlying event source storage, and you can find a project which we used as inside a GitHub in the PyDot liiklus repository. This event gateway is built on three main points, which are being reactive and support back pressure, uh, non-blocking APIs, and so on and so forth, provide us a nice gRPC interface or RSocket interface, or actually quite extendable and pluggable. So any kind of feature is possible to implement via pluginization mechanics. These are transport layer, storage layer, or metrics. So event gateway is our facade before our event storage, these are Kafka or any other storage. And we experimented with different stuff, even with PostgreSQL, and services actually didn't notice anything about what kind of storage or what kind of event source is behind of that kind of gateway. Because gateway itself provides nice gRPC provided API to communicate with and maintains own state and own pluginization mechanics. When we finally migrated all the microservices we actually had at that moment not that many microservices, and that paid off later on. We started to look into Pulsar. Pulsar from the very beginning provided us quite better developer experience. It was nice official documentation, quick start guides there were quite nice examples on how to use their non-blocking client, and with their non-blocking client, it was easy to adopt within the Reactor wrapper and communicate reactively with Pulsar. And more than that, Pulsar provides stateless brokers and decoupled storage abstracted with Bookkeeper. Bookies provide quite nice experience operating ledgers, and yeah, that was easy from the maintainability perspective to deal with the storage and update Pulsar itself and do whatever we wanted to extend it later on. What kind of discoveries we found during the adoption of Pulsar? First of all, subscriptions. Pulsar provides some subscription models, be it shared, extensive, or per key, as well as few other. We first started as a shared subscription model and found that actually not everything is that obvious. If you use non-standard and not really defined in documentation features, so when you use separate acknowledgement and seek mechanics, we use that for better reliability and portability. For example, that was quite useful when we migrated between Kafka and Pulsar. We offload all the offsets into a separate database via our plugin in Event Gateway. And whenever new client connects to event storage, we actually first get the latest offset from this database and apply it during the seek of the new position. However, when your group and subscription is shared between different instances, one instance is reading and second is load balanced recipient and reads other partitions, whenever the first instance dies unexpectedly, all the subscriptions will remember, all the partitions will remember what kind of latest seek was uh, provided by this died consumer. And the second consumer wouldn't know that no one acknowledged anything later on, and would start to receive all the events were already processed by instance, the first died instance. And that leads us to situation when any kind of reconnect reset subscription to the latest seek, but dying wouldn't reset anything or move anything. And that would lead us to the random huge redeliveries where we cannot predict at which moment we will start processing new events and what kind of events that would be, and were they processed at all or not. Mostly our system designed in attentional consistency expectations and would know that repeatable event should be able to apply twice. However, it's hard to predict all the use cases and all the corner cases when random redelivery from random point of time would happen. So we try to adopt another subscription model, which is called exclusive. So exclusive subscription model brings us fixed for this redelivery mechanics, but at the same time gives us other downsides. For example, it brings us to a state which we could call like hungry instance. So if instance would have requests to subscriptions for all partitions, and the second instance would try to do the same, only the first instance would acquire all of them, and the second, if it would try to connect a second later, that service would stay idle with rejection of all the connections. One more possible variant which could serve as well in that case is a subscription for key. However, we're still experimenting with that kind of approach and cannot share any thoughts on that yet. However, that looks quite promising, and we love that Pulsar brought it to the feature list. One more thing I have to mention across all the features we have in Pulsar is a tiered storage. As I mentioned earlier, event sourcing requires infinite retention pivot if you want to replicate any point of time as a new aggregate and provide a new state of that kind of data. And if you don't use snapshots, it has to be persisted on some long-term storage and back it up quite carefully and provide opportunities to investigate more details later on. So when we have to deal with enormous amount of events, what we can do is offload anything to some cold storage where we don't use that often. So the reprocessing itself happens only when we launch a new microservice, and that doesn't happen really often. Or it's nice to have and sort of provides that opportunity as well. For our setup explicitly, what we can mention as well. So authorization using pause requests and connection was super easy and nice to set up. Pause JWT and mutual TLS, we set it up just with a few properties in configuration file and the simple generator, which provides us self-signed certificates. We use currently not very big instances. It's way less than recommended by the official documentation, but that totally enough for our workloads. And that's M5 large instance, three instances, one per availability zone per component. So Broker, Bookkeeper, and Zookeeper have 3 instances in total. We deploy everything with CloudFormation and using Troposphere, which is kind of top high-level Python DSL for definition, CloudFormation definition, which is currently maybe way better replaced by AWS CDK in some terms. So if you're familiar with AWS CDK, you could understand what is Troposphere. That is quite convenient to set up the underlying hardware. We don't use Terraform for that. However, one of our mistakes were that we used the user init to set up Pulsar itself and do everything required to launch it. As you may know, user init scripts in AWS would wipe out the entire instance in case you would change even a symbol in there, and that is quite dangerous when related to something where you have to keep the storage. As well, sometimes you cannot really control how long and in which order all the instances would be spawned. And because of that, we could end up in a situation where all the instances would be wiped out at the same time in parallel, and we would lose all the data from our storages. So we decided to not risk anymore and frozen all the user init scripts to their initial state, and now use Ansible with all the necessary steps to set up Pulsar properly. Within the Ansible, with Ansible, we use AWS System Manager that could execute all the playbooks we need, and yeah, update via AWS commands everything within the Pulsar cluster. The interesting story for GDPR cleanup from the storage. So as you may know, GDPR provides you a capability or provides you a way to clean up all the data you want in organization you communicated with. When GDPR was quite new, there were many discussions on how to deal with cleanup of events of storages like Kafka or Apache Pulsar. Can we just encrypt everything and throw out the key after that? Will be that the way to go? No. We could say that encryption is not the way to go because data is still there. You can imagine that in 10 years, something could happen with computer science, with hardware, and current algorithms, which could be used potentially to encrypt all the data, could be broken or decrypted without even knowledge of the key. And sometimes personal data or the fact that personal data is still there could be still relevant even in 10 or 20 years. So what kind of options we have besides that encryption? First of all, we've tried migration to a clean topic. Migration to a clean topic is a nice way to go when you don't have anything. You just copy all events, all the necessary data from one topic to another clean one, except for filtering out all the events you don't want to be there anymore. And then switch gracefully to that new topic to read and write. Or since you cannot really synchronize a point where everything stops reading and stops writing, without downtime. It requires this kind of downtime along with some manual actions. So to do that, on our case, we had to deal with 17 manual steps. That's quite a lot to bring up every few days or weeks, even sometimes months. It's super hard to do. We tried to automate that with separate service, which would do all the heavy lifting, or with Pulsar functions. And I even tried to test that out with a library called test containers, which were quite helpful. So Apache Pulsar provides a model built in into test containers, and you can start that in tests, throw some events, try to migrate a topic locally with Java code and service you wrote or Java functions, Pulsar functions. However, that didn't work for us well because of this approach simply doesn't scale. So we found another solution which we currently use, and that's offloading to some external storage of all the sensitive or personal information, and then put in Pulsar only reference to that. You could read more about that kind of approach if you search for a claim check pattern. Then anything you want to clean up, you just do separately in this database. You kill everything in database, kill backups, and that's it. Pulsar doesn't have this kind of information. You don't have to do anything with Pulsar itself. Maybe one of the wishes we would have is issue 5059 for key cleanup. That would save just tons of time implementing and experimenting with this kind of cleanup. That would be really nice and huge addition to feature list of Apache Pulsar. So Apache Pulsar actually have topic compaction, and topic compaction is a nice way to deal with cleanup, regular cleanup, but not really nice and right approach to deal with GDPR related cleanup, where you have just one key requested to be cleaned. So would be nice to have that kind of mechanics and yeah, do not write anything aside. During the adoption of Apache Pulsar, we've read quite a lot of documentation and source code. So I could say that official docs are actually the best starting point, and that helped us a lot for understanding. And sometimes you can't really get everything written from the first time. And I've read, I think, 5 times the entire documentation until I remembered everything and understood finally some concepts. However, it was a super nice experience to read, understand, and apply in uh, the project. Or documentation itself is not really sufficient to write a good code, and I would highly recommend to start with examples. And one of the examples, especially when you migrate from Kafka to Apache Pulsar, could be Kafka Pulsar sources. So recently, Team Apache Pulsar implemented that kind of connector or interface where you can communicate with Pulsar via Kafka interface, and that's a really, really nice source where you can look at how client could be used, what kind of things you have to remember, and what kind of differences would you have between Kafka and Pulsar. And obviously worth mentioning is Slack, official Slack, where you can get quite a lot of help from community members as well as developers, which react really fast and help a lot. So I even had a case where I found a small issue, with memory leaks related to actually acknowledgements we don't store on the Pulsar. So that kind of client issue was fixed just in a few hours in the master branch. So I really like the way it works in Slack. What kind of takeaways I could mention from the entire story? First of all, flexible subscription mechanics. You can choose whatever you would like. And how would you deal with Pulsar? These are exclusive when all clients would not be able to connect to Pulsar except the first one shared where it would be automatically load balanced, but take care of acknowledging all the events in the right place and the right time. Or per key subscription, which looks like delivery of several separate messages ordered, and that's really nice experience. Or that requires some changes in our oral system to deal with that. It provides quite nice developer experience. So both client, non-blocking client, all the code, all the installation process is super nice. Test containers model helps here a lot. And learning examples by examples in code provided by official repository, a lot of community samples already, blog posts provided help here a lot. And I think that's it from my side. Yeah, please contact me if you want more details or yeah, just chat around. And yeah, thank you.